Welcome students, this is a quick summary of section 2.4 on measures of spread. We are still on a chapter on descriptive statistics where we're trying to summarize our data in a nice, concise way. Last time we studied measures of location, measures of central tendency. Let's take a look at the following two sets of data. First data set is going to be in red. So here is my set of points. And second data set is a blue one. All right. If we calculate, let's say, arithmetic mean for both of these data sets, we'll get very similar results. However, if we take a closer look at these two data sets, we can see that they are very different from each other. And the blue data set is more varied. It has a greater dispersion than the red data set. So to measure, we use measures of spread to measure variability, dispersion, the spread of our data. And the first measure of spread that we are going to study is the range. The range is simply the difference between largest and smallest values in our sample. Let's take a look at the following example. Here we have two data sets. We can see that average of both of these data sets is equal to 200. However, we can see that the first data set is more spread out than the second one. Okay, let's calculate range for these two data sets. So range for the first data set is going to be equal to 226 minus 177, which is equal to 49. Range for the second data set is going to be equal to the largest value of 209 minus smallest value of 192, which is equal to 17. All right, so by quickly calculating the range, we can see that the first data set is more spread out. The next measures of spread that we are going to study are percentiles. Even though it's very easy to compute the range, it is very susceptible towards outliers, and it's insensitive towards other data sets other than largest and smallest values. So if we have, let's say, two data sets with the same largest and smallest values, but a different spread in between, it will show that both of these data sets have the same range. And on top of that, when we increase our sample size, the range is going to also increase. All right. Next measures of spread are percentiles. Percentiles are a special case of quantiles. So we use quantiles to divide our data set into equal-sized continuous intervals. If we want to divide our data set into two intervals, we use a median. So median, the middle point, is going to divide our data set into two intervals. If we want to divide our data set into 4 intervals, we use quartiles. 10 intervals, deciles, and 100 intervals are percentiles. Okay. Informal definition for percentiles is P's percentile is the value big P, such that P% of data points are less or equal than our big value P. So we divide our data set into 100 equal-sized intervals. Let's take a look at the following problem. Jennifer received her SAT score. Her SAT math score is 600 and is in the 75th percentile. What does that mean? It means that 74% of other students scored less or equal than her score of 600. And 26%, the other 26% of students scored better than her. There is no single standard definition for percentile. And unfortunately, if our data set is small, they might give us extremely different results. However, all definitions will yield more or less same results if our data set is large. I will be using the definition given in our book, which is defined as follows. First of all, we are going to look at the value of NP over 100. And if it is not an integer, let's assume that we have 10 sampling points, so small n is equal to 10, and we want to find 35th percentile. We multiply 10 by 0.35, which is equal to 3.5, which is not an integer. We are going to take the k plus 1's largest sample point, where k is the largest integer less than our 3.5. In other words, we take integer part of our NP over 100, integer part of 3.5 is 3, and we are taking fourth largest sample point as our 35th percentile. To find fourth largest sampling point, we have to order our data set in an increasing order from smallest to largest. In the case when NP over 100 is an integer, let's say we are trying to find a 30th percentile. If n is equal to 100, NP over 100 is then equal to 100 multiplied by 0.3, which is equal to 30. Then our 30th percentile is going to be average of 30th and 31st largest observations. Okay, let's take a look at the following example. Let's compute 10th and 19th percentiles for our data set here. We have 20 sampling points, so our first step is to arrange them in ascending order from smallest to largest. Then we should find 10th and 19th percentiles. So 20 multiplied by 0.1 is 2, 20 multiplied by 0.9 is 18. And our 10th and 19th percentiles are defined as average of second and 2 plus 1 third largest values. 19th percentile is calculated as average of 18 and 18 plus 1's largest observations. So average of 18th and 19th largest values. All right, in the case, let's take a look at another example. We should compute a 20th percentile. We have 9 sampling points. 0.2 multiplied by 9 is 1.8, which is not an integer. So we again start by ordering our sampling points. Then 1.8 is not an integer. We take its integer part and add plus 1. So we should take a second largest observation, which is a value of 5. Okay, so percentiles, as we said before, percentiles are special case of quantiles. Quantiles divide our data set into equal-sized continuous intervals. All right, so we have gone through this already. Now quartiles. So we use quartiles to divide our data set into 4 intervals. There are 3 quartiles. First quartile is a value which is greater or equal than 25% of our data. Median is greater or equal than 50% of our data. And third quartile is greater or equal than 75% of our data. Okay, let's take a look at the following example and let's calculate quartile for it. Again, we start by ordering our sample in ascending order. To find median, we have 18 observations, meaning that median is the average of middle 2 values of 9th and 10th observations. All right, now to find the first quartile, Q1, then we have to find the median of the first 9 points. So we have to find the median of the first half of points. So here are my first 9 points, and it's 5th largest observation in it. So Q1 is 735. To find third quartile, we have to take other half of our points, other 9 points, and again we have to find middle value of other half of these 9 points, which is fifth largest observation and has a value of 4668. All right, interquartile range is the middle 50% of our observations, and we calculate it as the difference between Q3, third quartile, and first quartile, Q1. And finally, the ultimate and most popular measure of spread. These are the variance and standard deviation. One approach to measure the variability in our data would be to measure the deviation of our sampling points from their mean. Let's assume that we have following data set. Here is our sample mean, and we can calculate the following sum average of deviations from our sample mean. In other words, to calculate these distances over here and take their average. If we take a closer look at this formula over here, we can see that it is exactly equal to 0, since the positive deviations will cancel out the negative ones. One way to deal with that problem is take an absolute value of those deviations. And this does work and sometimes is used, and it is known as mean deviation. However, it is troublesome mathematically since absolute value function does not have simple arithmetic formula, nor it is differentiable. To deal with the differentiability problem, we can take the following approach and calculate the sum of squared deviations from mean. And this does work, and it is known to be as a best approach. This formula over here with n minus 1 in denominator is known as variance. The reason why we have n minus 1 in denominator will be clarified later on in this course. We still have one small problem. If you take a closer look, you can see that the units of if let's assume that units of our variable x is in meters and variance will be in meters squared. To deal with that problem, we can simply take a square root of variance. And this variable is known as standard deviation. Standard deviation is the square root of variance. Now let's take a look at a couple of useful properties for variance and standard deviation. Let's assume we have original sample of x-size. So let's assume here are my sampling points. And we have another translated sample by some constant c. If we take a look at these values on a real line, these values, they are going to be shifted by some distance c. Now, if you look at x-size and y-eyes, you can notice that variability of those two didn't change. Now, let's show that. Variance is usually denoted as sigma squared or small s squared, and standard deviation is denoted as sigma or small s. We use this small s notation for in our book. Now, variance of translated sample of y-eyes is calculated as the sum of y bar minus yi squared over n minus 1, sum from 1 to n. Now we know from properties of arithmetic mean that mean of translated sample is calculated as x bar plus c. Minus yi is xi minus c, and minus 1. So these c's are going to cancel out. And we are simply left with the formula for variance of original sample of x's. This is sigma x squared. All right, when we are working with translated sample, the variance will not change. Let's see what happens in a case when we have scaled sample. So let's assume we have original sample of x size. Scaled sample is y i's. We multiply our original sample by some constant c. Now let's take a look at the value of variance. Sum from 1 to n, y bar minus yi squared over n minus 1. Now we know from properties of translated sample, of arithmetic mean for translated sample, that y bar is equal to c x bar minus yi is denoted as c xi. We can factor out constant c. And this is exactly the formula for variance of original sample x of xi. So c squared. So variance of scaled sample is equal to c squared variance of original sample. Then standard deviation or c is going to be equal to s is going to be equal to c multiplied by standard deviation of original sample. All right, guys, this is going to conclude our summary for chapter 2.4. This couple of properties for variance and standard deviation. This is subsection 2.5. See you next time. Have a good day.